Hello class. Today a short video that will just help you with the multiple linear regression lab session that you're supposed to complete this week. Of course, everything that's useful for the lab session is also useful for your homework. So the first thing is I want to make clear what is it they're asking for when they say interpret the y-intercept. We saw in the lecture that the y-intercept doesn't always have a very meaningful interpretation. However, it always has a mathematical interpretation, and that interpretation is that it is the value of y when both x1 and x2 are 0. Now, of course, sometimes you can add that this is not a very meaningful estimate when one of the x's, for instance, cannot have the value 0 by definition. But mathematically, this is still what the intercept means. The second thing I'd like to say is that sometimes Pearson asks you what conclusions can you reach at the end of a series of questions. And in that case, so here, for instance, you have this long question about a shoe manufacturer developing a brand of running shoes, etc. It's using durability as its x variable, x1 variable, shock absorbing capability as its x2 variable, etc. When they're asking you about the conclusions that you reach around concerning durability, which is the y variable, so these kinds of questions are just asking you what are the variables that are included in the model. And so depending on what answers you got from your analysis, you're going to say something like this: the model uses both this variable and that variable to predict the y variable. You will get several questions that ask you to compare different models, meaning compare different predictions with different variables included as the regressors. So here's an example where you have to first develop a regression model to predict price to book value based on return to equity. So that's one y variable and one x variable, the x1, return on equity. Then you have to do the same thing with the other variable that they give you, which is growth. And then you have to do the same thing with both variables included in your regression. Okay, so how do we actually get these? Well, you just have to run 3 regressions in Excel. It's not that difficult. You have this data here. This is your y variable. These are your 2 potential x variables. And so you're going to run 3 regressions. First, you run a regression that is just the regression of the price to book value on just the returns to equity, so just on the B column. Then you run a second one that is just on the C column, and then you're going to do one that is on both the B and the C column. Notice that here I actually have them reversed. The C column is supposed to be an X variable. So here you should have the A column as the Y and B to C columns as the X range. I personally like to specify the output range so that they're all on the same page, one under the other. It makes it much easier for me to read. You can also just have them output to a new workbook. It doesn't matter that much. It's whatever feels right for you. So then they ask you to judge which model is the best, and how are you going to do that? We saw it in the lecture. You're going to be comparing the adjusted R-squared. So the model you will choose that has the best predictor is the one that has the largest adjusted R-squared. Be careful not to pick the R-squared. It's the adjusted R-squared because this is a multiple regression. So if you have multiple variables, you should be using the adjusted R-squared. Here's a kind of question that most of you really dislike because it forces you to do a little bit of computation. These computations are easy to do in Excel as long as you know the formulas. So here, for instance, they're asking you to compute the R-squared. The R-squared is the easier one to get. It's the sum of squared regression divided by sum of squared totals. It's right here. It's this divided by that. Okay, now the problem is when they ask you to do the adjusted R-squared, and that one is a little bit harder, right? It is this, but you just computed R-squared, so you can just plug this into here, and then all you have to do is add in all of these calculations. 1 minus all of this thing, you compute n minus 1, you compute n minus k minus 1. If you're worried that you don't know what these n and k might be, what is k? It's the number of variables. So here, k is just 2 because you have 2 variables. And almost always in these questions, you're going to have 2 variables. And what is n? N is just this number plus 1, right? You can just read it off of here. This is the degrees of freedom. So this is n minus 1. Therefore, your n is 19. And so you can just plug in these values and you will get your adjusted R-squared. It's not difficult. keep these slides handy so that in the homework or in the test, you can easily just go back to them, take a look, and plug in everything. Or even better, make yourself a calculation sheet in Excel that already has this formula, and then in the test, all you have to do is pull it up, plug in the value for n, plug in the value for r squared, plug in the value for k, and everything follows. You will also get questions about how to add an interaction term. So here, they are already giving you a full equation with the y hat being predicted on the x1i and the x2i. And they're asking you whether you can find evidence that the interaction term is a significant contribution to the model. So you're starting with an already complete model and you just want to add an interaction term. What's the interaction term? It's, like I said, x1 times x2, but you treat it just as if it was a third variable. You compute this cross product and you treat it as if it was a third variable. And it's going to get a beta 3, and you're going to determine whether this beta 3 is significant or not. So the good thing is they really take you by the hand. They tell you exactly what they want you to do. They say let x3 be the interaction term, and they tell you how to define it. So all you have to do is just create this new variable. How do you create this new variable? You do it in Excel. This is the data that they gave you. All you need to do is, in one more column, you create a column C times column D interaction variable. You just do it for the first row and then you drag it down. Then you run your regression with all three of those variables, and depending on whether your beta is significant, which you read by looking at the p-value, for instance, is the p-value less than 0.05, then you can decide whether or not the new model is more appropriate because you found a significant beta 3, or not more appropriate because you did not find a significant beta 3. Again, in these kinds of questions, some of these answers don't make sense at all. For instance, here, the new model is more appropriate because the interaction term was not significant. That doesn't make any sense. It would only be more appropriate because it is significant, or it would not be more appropriate because it is not significant. So it's always going to be either it is more appropriate because it is significant, or it is not appropriate because it is not significant. Okay, you will also get some questions about trend forecasting. Be careful when you do those. The first thing you need to do is count the periods starting from 0, right? So if your x variable is years and the data they give you is expressed in the year 1966 to 2004, the first thing you need to do is create a new x that starts at 0 for 1956 and continues on 1, 2, 3, 4, 5, etc. So you need to make the variable that has the first year xi equals 0. How would you do that? Well, let's say Pearson gave you this data set. You'll notice it's a little bit different. It starts at 1986 this time. As you know, Pearson gives you a different data set every time you click, so this is a different problem. They gave you this, and what you want is to add this column right here. So you're going to push the GDP, and you're going to insert a column here. How do you make that? All you need to do is in cell B2, you set it to A2 minus 1986, just so that this one is 0, and then you drag down. You take this and you drag it down, and that is your period variable. Then, of course, when you run your regression, make sure you are running your regression of GDP on the period, not on the year, right? You want this new transform variable to be the one that you regress with. And then again, once you ran this regression, you have to be careful that when you plug in the year, you don't plug in just the year itself, you plug in the year minus 1986, because that's what you use to rescale all of this period variable. So in your prediction, you're not using the actual year, you're using the period number, which is the year minus 1986. And that's it. Those tricks should really help you with your lab and with your homework and ultimately with your exam.